आंसर रिकॉर्ड कर. So guys, I am recording this lecture third time. So I don't know why my voice has not been recorded. So on this time the voice has been recorded. So I will explain you the approach, that what approach I have been followed. So basically, uh, let's try to understand that first. So we are already covering the brute force approach, and we have to optimize it. Okay. So if I want to optimize, what I understand here is that, okay, for optimization, first of all, we have to understand one thing, that if there is any composite number, okay, if there is any composite number, then that composite number can be formed by multiplying two numbers. Okay. And that two numbers are basically the factors of that composite number. Okay. So if I basically there are two numbers, A and B, and if I multiply, we get n. So basically, after multiplying these two number, I got the value is equals to n. It means that this both numbers are basically the factors of this composite number. So if we consider a composite number, suppose 36, then we can write it like this: 1 into 36, 2 into 18, 3 into 12, 4 into what? 4 into 9, then 6 into 6, then 9 into 4, then 12 into 3, then 18 into 2, and then 36 into 1. Now, if you observe carefully, we write this as pivot point. So why I call this as a pivot point? Because if we see here, after this point, here I will write 4 into 9. Here I will write 9 into 4. So basically, I will multiply, if I multiply 4 with 9, or if I multiply 9 with 4, both are same things, right? If I multiply 3 with 12, or if I multiply 12 with 3, both are same thing, right? So if I see after this pivot point, the value has been repeating. Okay, 9 into 4 and 4 into 9, 12 into 3 and 3 into 12. Okay, so basically values are repeating. And if we see carefully, basically this both A and B. Okay, so basically these are A and B. And what I see that, okay, means these are factors, right? So if these are factor, what I've seen here is that this is 1, 2, 3, 4, 6. And after that, if you see here, this is 6, 4, 3, 2, 1. So the basically value has been repeating, or one of the divisor, if I see, one of the divisor is always lesser than equals to a pivot point. That I think so it's right. Okay. So if I see that one of the divisors is always lesser than equals to a pivot point. So for a 36, the pivot point is 6. So for any n, the pivot point is what? Under root n, right? Under root n. So why under root n? So for 36, the pivot is 6. So what is 6? If I take a square root of 36, I got 6. So if that, if at the place of 36, there will be n, so what is the pivot value then? So basically the pivot value will be under root n. So one thing I understand is, okay, so if I have given a number, and if that number is a composite number, what I understand here is that, okay, composite number can be formed by multiplying two numbers. And that two numbers are basically the factors. And what I also understand is that one of the factor is always lesser than equals to a pivot point. So what is that pivot point? Pivot point is basically that under root n. Okay, so what happen is we are considering three situations that, okay, what if we take both A and B is greater than under root n. So if we take both A and B is greater than under root n, what we are observing here is that charger, tab ka charger. So what we are observing here is that A and B, if I take both values greater than under root n, then after multiplying, we get value greater than n. And if we take both value less than under root n, then we get the value uh, less than n. Okay. Now, if we take both values equals to under root n, then after multiplying, we get values equals to n. But one thing we are observing here is that we are continuously changing the divisor, right? We are continuously changing the divisor. So it means that one value must be increased. So if what I understand here is that, okay, if I increased one of the value, if I increased one of the value, and suppose if I try to increase another value, so it means that I will never reach till n. And if I decrease one of the value and if I decrease another value also, then I will never reach till n. So it means that if I increased one of the value, I must have to decrease one value. So if I decreasing value and if I increasing value, then what is the maximum limit till which one divisors must go? So the maximum limit till the one divisor must go will be under root n. Because suppose if a is greater than under root n and if I take b, which is also greater than under root n, then I will never reach till n. So it means that one thing I understand here is, and also we are observing it here, that one of the factors must be less than a pivot point. And what is this pivot point? This is basically under root n, right? So what I understand, okay, if there is a number given and I want to check, okay, this number is a composite number or not, what I know that there is one factor which is always less than equals to under root n. So I will start from 2 and go still under root n. And if I check that, okay, any of the number divides n, it means that basically this number is a composite number. Okay, so what I will do, I will start from 2 and go still under root n and I will check, okay, this number divides n on it. So if that number divides n, it means that that number is a composite number. And if it not divides n, it means that this number is not a composite number. It means that that number is a prime, right? So hope so you understand that. And what we have to change in the code. So you have understand the code previously, right? So wait a moment. I will show you. I just have to copy this. Okay. So if you see carefully, that one thing we are changing here is previously we are starting from 2 and goes till n minus 1. Now one thing we are changing here is that we are going still under root n. Okay. So one thing we can use here is sqrt function. Okay, sqrt of n. But what is the problem? We will learn about this in future classes that sqrt function will take log n time. Okay, so we are not using that sqrt function. Rather than this, we are using the simple mathematical concept that is what I know that I must be less than equals to under root n. Okay, so I will square it both side. After squaring, I will this under root has been removed and I got 2 here of in the power. And we can also write it like this: I into I is less than equals to n. So one thing we have to change here is just that I will multiply it with I and I will remove minus 1. So this is the optimization. And what is the time complexity of this? So time complexity will be big of under root n. Hope so you understand it. Okay, so this is basically the optimization, but this is not the end. We will learn one more optimized way of checking a prime number. So basically that optimized way will not reduces the time complexity, but it will reduces the CPU computation. And this optimization will make our code 3 times faster than this code. So let's check it and let's observe it. Okay. So let's consider we have given n is equals to 101 and we have to check that, okay, this number is prime one. right? So if that number is prime or not, what we will do, we will start from 2 and go still under root n. So also under root of 101 is approximately equals to 10 point something, which is 10. So what we will do, we will start from 2 and right, we will check it with 2, 3, 4, 5, 6, 7, 8, 9, 10 here, right? Till 10. But one thing we are knowing that is that if any number is not divisible by 2, okay, then that number is also not divisible by 4. And also that number will not divisible by any of the number which has factor 2. Like, you have to understand this that, okay, so the minimum value even number will be 2. Okay, so any number is not divisible by 2. It means that it will never divisible by that number also, which has a factor. And second thing we have to understand here is that, okay, if any number is not divisible by 3, then it is also not divisible by 6 or 9 or 12 or 15 or any of the multiples of 6. Okay, so that is the first thing we are observing. So I will check that, okay, will this number is divisible by 2? So if this is not divisible by 2, what I will do, I will cut it out. That, okay, it is not divisible by 2. It means that if it is not divisible by 2, it will never divisible by 4 also. Never divisible by 6 also. Never divisible by 8 also. 10 also. Okay, and suppose if there is a 12, then also not with 12, not with 14. And let's take this example. And just understand the concept. So suppose if this is a number and if this is not divisible by 3 also. Okay, if this is not divisible by 3 also. So if this is not divisible by 3 also, it will never divisible by 6, it will never divisible by 9, it will never divisible by 12 or 15. Okay, so if we see, we are only left with what? We are left with 5, 7, 11, 13, 17, 19. So what is this 5? This 5 is basically 6k minus 1, and this 7 or whatever these numbers, these are in the form of 6k plus 1. Okay. So here k is equals to 1. So if I put k is equals to 1, 6 into 1 minus 1, which is 5, 6 into 1 plus 1, which is equals to 7. 6 into 2 minus 1 is equals to 11. 6 into 2 plus 1 is equals to 30. So what I've seen here is, initially we will check that, okay, if this number is divisible by 2 or 3. If that number is not divisible by 2 or 3, it means that it will never divisible by 4 or 6 or 8 or 10 or 9 or 15 or 14 or 12 or whatever. Okay, so we only have to check with 5, 7, 11, 13, 17, 19. So we are start with 5. Okay, we are starting with 5. And what I will do, I will check that, okay, if that number is divisible by either a 5 or a 7. So if I is equals to 5, what is 7? I plus 2. So at same time, I will check with two numbers. So what I will do, I will take this number. Okay, so I will start from 5 and go still under root n. This will not change. Okay, and what I will do, I will take the modulus with I, means 5, and check, okay, will this number is divisible by 0? Or sorry, will this number is divisible by I? And also at same time, I will check that, okay, will this number is divisible by I plus 2? Means 5. If I check with 5, I can also check with 7. If I check with 11, I can check with 30. If I check with 17, I will check with 19 also. Okay, and if that number is divisible by any of this, okay, any of this, it means that basically this number is a composite numbers. Because what I know that if this is a prime number, it will never has been divisible by any other number uh, except one in itself. Okay, and if we see carefully, first we are checking for 5. After that, in next time, we are checking with 11 and 13. In next time, we are checking with 17 and 19. So how will we jump on 11 directly? So basically 5 plus 6 will be 11. So after 11, we have to check with 17. So how will I get 17? 11 plus 6. So what we will do, I will start from I is equals to 5 and I will take the jump of 6 here, not 1. I will take the jump of 6 here, and this is basically the logic. So if we see carefully, previously what we are doing here is, so for 101, we are checking with 2, 3, 4, 5, 6, 7, 8, 9, 10. So basically these are 9 times CPU have to do this work by checking with this each number. But if we understand this concept, so what we are doing, we are only checking with 5 and 7. So how many times the CPU has to do this work now? They have to do only 2 times. So if you see, previously it has to do basically 9 times work, and currently now it has to do only 2 times work. Okay, so what we are doing here, we are basically optimizing it, or we are making our code 3 times faster, and we are optimize it on CPU level, not in the time complexity level, but we are optimizing it on CPU level. So this is also the one way of optimizing the prime factors, or basically knowing that if that number is a prime or not. So if we see the code, okay, I will paste it here. Wait a moment. So this is basically the code. What we are doing here is, if I get a value 0 or 1, what I know, 0 and 1 is not a prime number. So I will write that, okay, no, this is not a prime number. Except that what I will get 2 and 3. What I know, 2 and 3 are basically prime numbers. So I will see that, okay, if n is lesser than equals to 3. So we are already checking for 1. So we are left with 2 and 3 only. So if I get 2 or 3, I will print that yes, they are primes. After that, what we are doing, we are checking that, okay, if this number is divisible by 2 or 3. So if that number is divisible by 2 or 3, it means that this number is not a prime. Because who is prime? Prime number is the number which is only divisible by 2, not 2. Prime number is a number which is divisible by 1 and itself. Okay. So we are already checking for 2 and 3. So it means that 2 and 3 will never come here. So it means that any other number will. And if any other number will divisible by 2 and 3, it means that that number is not a primary. Okay. So if this condition is not passed, it means that I have to check it from 5 to under root n. Okay. And I will take the jump of what? I will take the jump of 6. So I will start with 5 and go still under root n, and I will take the jump of 6. And what I will do? I will check with I and I plus 2. So what I will do? I will take the modulus with I, and I will take the modulus with I plus 2, and I will check that, okay, from I or I plus 2, any of the number is dividing this number. What number? The number, I have to check that if that number is a prime or not. If that number is not divisible by I and I plus 2 also, after iterating over whole loop, it means that this is basically prime, and otherwise this is basically a composite number. Okay, so this is the optimization code. Hope you understand this. So basically, I was recording this video third time, so that's why I am already explaining it 2 times, and then I will see that, okay, basically the video has not been recorded, and also on next time I will see that, okay, sound has not been recorded. So hope so you have understand the approaches. So there are two video come on daily basis, one on 11 a.m. on the morning, and second video will be on 7 p.m. on the evening. So I will I will try to cover all the concepts that is present in competitive programming and DSA. Okay, and we will try all types of problem and also the new problems also which will become in OA interviews. Okay, and in the code courses or lead code or add coder contest. So we will try to do that questions also. Okay, so that any of the, if you are in any of the year, you can follow this. It will take a time, okay, because I am also studying, okay, and I am also preparing for placement. So if I get a time, mostly I will upload the lecture on daily basis. Okay, and if you want to join this, you can connect with me. You can subscribe to my channel, and on daily basis, you will get some newer questions, some newer concepts, and you can try that question, try to solve it, and this is how we can prepare. So, hope you like this video. Till then, take care. Bye bye. Enjoy your life, and good night.